let us have a look at environmental footprints. Environmental footprints are indicators that use specific units to represent our impact on the environment. And indeed, we're interested in the carbon footprint. Okay, so how much CO2 do you emit per year? What's the average CO2 equivalent emission per person? Okay. So this lecture has 3 parts. On the first part, we look at the carbon footprint. I will also give you an example of planting a tree. How much CO2 emission do you offset by doing that? And I give you several other examples of CO2 equivalent emissions. But indeed, we're not only having a carbon footprint, in terms of global climate change, this is relevant, but it's also water footprint. In particular, in the prospect of a changing water cycle. So the second part talks about the water footprint. I introduce you to blue, green, and gray water, food and product water, and nations water. We do some comparisons. In the last part, we also look at the ecological footprint. It's about the biocapacity of the planet and how much we use the ecological footprint. Okay. And at the end, we're coming to the conclusion that we are in a dilemma. So let's start talking a little bit about the carbon footprint. So how much CO2 do you emit? Okay. So the carbon footprint measures the amount of CO2 equivalent emissions in metric tons per year that are produced by an individual, an activity, a process, a product, a service, or by a country. Okay. Here are some relevant questions. Travel carbon footprint. How much CO2 equivalent gases emit during a trip? Which transport systems have lower emissions? There's a product carbon footprint. How much CO2 equivalent gas is emitted to produce a product? Okay. Food carbon footprint. How much CO2 is emitted to grow, process, and distribute food? These are the relevant questions. And there are many calculators available online. You can calculate your own carbon footprint. Okay. So let's have a look at the average CO2 emissions. Again, you just calculate it. What you need is the total CO2 emissions, around 37.12 billion metric tons per year, and divide this by the world population, 8 billion people in 2023. And you can work out that the average CO2 emissions per person, which is also called per capita, is 4.6 metric tons per year. Okay, that's the average. But however, it varies. And here's a map that shows you the per capita CO2 emissions in 2021. And you can see that there are countries where you get more a dark orange, almost darker area here where the emissions are more than 10 tons per year per capita. Again, you have other countries where you have less emission per person. Okay, you can see here in Africa there are many examples here. Okay, so the average CO2 emissions varies. Okay, but the developed countries, they use much more, or they emit much more of the CO2. So here's another very nice graph that summarizes carbon emissions. Okay, it looks a little bit busy here, but You know, what's shown here is there are different aspects of CO2 emissions shown. One is CO2 emissions per capita is on this axis, which points away from the Earth center here. So in this direction, you get CO2 emissions per capita, and then at the axis which runs around the globe here, this gives you for each country the population size. Okay, so that's why China has a much longer segment compared to smaller countries. Okay, so and if you do that for all the countries, you actually also get the area. So the area of each segment shown here is the total emission by a country, which is the CO2 emission per capita, which is one axis, and the other segment is the total population size. Okay, and this is a nice way to summarize carbon emissions per capita per country. And you also have the total emissions all in one graph. Okay? So now I wanted to give you that plant a tree equivalent. Okay? Here the question is, well, have a look at the average CO2 emission per person, and you work out, well, how many trees do you need per plant to offset this emission. Okay, so we just go through these numbers here. Average CO2 emission per person, 4.6 metric tons per year. One mature tree can absorb 20 kilograms of CO2 per year. 50 trees absorb 1 metric ton of CO2 per year. So the average CO2 emission per person can be offset by planting 230 trees per year. Okay. In Australia, the average emission per person is higher. In Australia, you need to plant 750 new trees per person. So if you thought about planting a tree initiatives, you have to sponsor 750 new trees per person, for yourself, and you have to make sure that everybody also sponsors in Australia 750 new trees, and you have to plant it without using any transport or without emitting more CO2. Plus, you have to actually wait maybe up to 10 years before you actually have a mature tree. Indeed, this entire, thinking about that, Anyway, so I don't want to comment on that. So globally, you have to plant 1.9 billion trees to offset the total carbon emissions. And indeed, that's not possible, given that suitable habitat is limited. And okay. But however, if you plant a tree, it has other benefits. Gardening is good for your mental health. That's number one. But also you can influence the microclimate. Okay, if you plant a garden, including trees, you indeed change, and you also have produce a habitat for animals. All right, so that's the plant a tree equivalent. So now we have a look at commuting. Okay, you're using a car, coming to uni. Okay. Say you live 10 kilometers away from this university. So you travel 20 kilometers a day, and a typical car emits 130 grams of CO2 per kilometer. And you're traveling 5,000 kilometers a year, means you produce 650 kilograms of CO2 per year. Okay. So it will take 32.5 trees to compensate for this emission. Okay. So that's the equivalent for you use your car coming to university. So I'd just like to mention that the European Union imposes emission standards and fines on car manufacturers. There are limitations on how much CO2 a car can produce, and we don't have that standard here in Australia. Okay, not yet. Okay, so that's why the cars that you actually buy here in Australia are significantly different from the cars that you can buy in Europe. Okay, because they are way ahead in terms of the technology in order to reduce CO2 emissions. Alrighty, so I mentioned there are carbon footprint calculators available online, but most of the ones that you can see are actually trying to get you to buy products, claiming of being more earth-friendly. Okay, so don't fall into this trap of buying some rubbish just because it says it's more earth-friendly. Like furniture polish here, there's one example shown here on top. Okay. All right, so let's have another look at other activities that affect carbon footprints of individuals' travel. Car travel, air travel, boat travel. All depends on the distance driven, the fuel efficiency. Okay. And, air travel depends on how many stops you have, because landing and short flights produce more carbon than one long flight. Okay, if you have multiple short flights. Anyway, so you can do some calculations, emissions per passenger per kilometer. We are showing you, here's my mouse, showing you estimates of how much CO2 is produced, including some secondary effects if you use planes from emissions and high altitude type of thing. And you can see that the biggest carbon footprint comes from domestic flights, relative. Well, it's not far away actually from cars with one passenger. And if you have 4 passengers in a car, it's a significantly reduced carbon footprint. That's the one issue that you have in Australia. If you look at that in cars, there are many cars with one driver only in it. It has a significantly higher carbon footprint compared to, a car with 4 passengers. You can also look at emissions within the home. Okay. The electricity use, how and how much electricity you create for your home per person. Okay. CO2 emissions within the home, almost half goes into heating or cooling. Okay, that's the biggest chunk. Lighting, 12%. Then you have refrigerator, washer, dryer, electronics, come to something like 15% altogether. Okay. Water heating, for hot water generation, 14%, and other 12%. Okay, again, heating and cooling is the biggest factor within your home. Okay. So now, activities affecting the carbon footprint of individual also includes what you eat and how your food is produced. And here are some comparisons of different types of food. So you can see there are these horizontal bars, and they are separated into different colors. And the different colors represent land use change is the darkest color. Then comes the farming, methane emissions, for example. Then comes the animal feed, and then the lighter colors are processing, transport, retail, and packaging. Okay? And this is expressed in kilograms of CO2 equivalent per kilogram of product. And you can see that beef is way the biggest number, 2.5 times more than lamb. Okay, and you can see cheese production is high up there. Okay, and chocolate, coffee, prawns, and then you get to some other products. And this is how you can compare products, different types of food. Okay, and you can see that the land use changes, and the farming and animal feed have way a bigger carbon footprint compared to transport, retail, and packaging aspects. Again, that's something that you can use in your strategy. You can now develop different strategies of what do you do, what food do you eat. Okay. All right. So that's the first part. That was the carbon footprint.